in the world of science like nowhere else. If you're not moving forward, you have no chance to compete. And we're doing that. We're growing. More faculty members, more graduate students, more PhD students, more master students.
Somebody who is young and who is interested and who is driven by the curiosity of finding things out.
It's a huge privilege to do something that you really like. Even if I didn't have to work 1 second, I would do exactly what I'm doing now.
You never really stop thinking about this. Just being a researcher, it's part of you. Yeah, it's not just a job.
When you travel around in the world, you see many, many universities. There is a lot of things that are common. What changes over the years are the details of what is fashionable and what is not fashionable. But there are certain things that are beyond fashion.
My name is Eitan Yacobi, and I'm an assistant professor at the computer science department. One of the exciting things which I'm currently working on today is how to store data inside the DNA. When I talk to people, everybody tells me we don't need storage today because you can store everything in the cloud. Because it's up over there, it's in the cloud, so we don't use the hard disk anymore, we don't need flash memories, everything is solved. But then I ask back, so where is the cloud? All of the big companies like Amazon, Microsoft, Google, they have big data centers. And what we want to do, we want to shrink them. So the capacity that we have inside DNA, it's enormous. So if I take a movie, I can convert the bits, the zeros and one that I have in my movie, into these bases, A, C, G, and T. It looks like a powder. So eventually we get a really small tube, and this small tube, we're going to have our movie, our files, our documents, our picture. So I can take a data center in the size of a football stadium and store it in something like this.
Programming today is like navigating before Waze or before even having a GPS. There's a general map. You roughly know where you are. You roughly know where you're trying to go. But there's this huge road system that you have to navigate to get from point A to point B. What we're doing in our research is trying to learn from how people navigated this world of code, how they solved a particular problem. And if we have enough information about your intent, about what you're trying to do, we can complete the rest of the program for you automatically. You can think of it like programming together with another person, but a person that has learned everything that there is to learn and has perfect memory. It becomes like a tango with a machine. You give a piece, the machine gives a piece. You give one piece, the machine completes the rest. You just tell me where you want to go, and the machine will take you there.
I was involved with computers from a very young age. I did play a lot of computer games, and I knew at a very early stage that computers is what I want to do. Yeah. My research field deals with spatial computing. Anything that involves taking a real-world object, representing it as a virtual object, and working with it computationally. It's like we're taking the real world and making a virtual copy of it. And at the moment, I think 3D printing is still kind of expensive, but when this thing is cheap enough, we will have the algorithms to enable the use of the technology. Basically, the algorithms will be good enough so that your kids can generate animated 3D models on their tablet. Let's say medical imaging, where I design a hip replacement, which is based on the 3D scan of a person and not just some generic option. I mean, geometry processing has been around for 20 years, but we still haven't really made it into people's homes. And I think it's not that far away, and it could be possible. Research is something that doesn't happen, in a locked room with somebody thinking really hard. It's basically a lot of ideas kind of meeting and exchanging and breeding new ideas.
There's some unit pride to this place that, we take it seriously.
These are the people that I want to work with. These are the people that I want to teach. These are the people I want to interact, to collaborate, and to be part of.
Science that comes from curiosity, from interest, is by far the most important science that is done in universities.
The Technion has this attitude that I can do better than anybody else, and I can contribute and I can do something really great.
This is the DNA of this place.
Much of what is done here, much of the research, will become significant in many years to come.
So the Technion is up there with the best of the best.